All right, welcome back. So really, I'm going to figure this out, and I'm going to essentially ask myself each time, are these mutually exclusive or not mutually exclusive? So let's start off with A. This is my table. This is what my outcomes look. There's 36 outcomes in total, right? 6 by 6 is 36 outcomes. And the probability of rolling a 12 is once out of 36, just so you know. So here we are, rolling two 6-sided dice and getting a sum of 2 or 12. So you either roll a sum of 2 or 12. You cannot roll a sum of 2 and 12. So this, I would say, is mutually exclusive. So the probability of rolling a 2 and a 12 is going to be the probability of rolling a sum of 2 plus the probability of rolling a 12. If we take a look, the probability of rolling a 2 is 1 out of 36, because it happens exactly once out of 36 times. Now, the probability of rolling a 12 is also 1 out of 36. So the probability of rolling, this should say a 2 or a 12 is 2 out of 36. The rolling two 6-sided dice and getting a sum greater than 7 or rolling doubles. So is there a chance of, now a sum greater than 7, now, so that means 8, 9, 10, 11, and 12. So can you roll a 7 and roll doubles? Well, yes, I would say. So like if you roll a 5 and 5, that sum is 10, but you also roll doubles. So this is not mutually exclusive. So I'm going to have to use that formula, the probability of A plus the probability of B minus the probability of A and B, right? That's the formula that we would have to use to get the probability of A or B occurring in non-mutually exclusive events. So the probability of greater than 7 or the probability of doubles, I'm going to say is equal to the probability of greater than 7 plus the probability of rolling doubles. Oof. And create some space for me here, minus the probability of greater than 7 and doubles. So the probability of rolling greater than 7. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I believe I am counting 15 outcomes that are greater than 7. So that would be 15 out of 36. The probability of rolling doubles, so double 6s and double 5s. And we have to include double 4s, double 3s, double 2s, and double 1s. So that occurs 6 out of 36 times. Minus the probability of greater than 7 and doubles, and that occurs exactly 3 times. Nope. Yep. 8, 10, and 12. So what we get, if I add those up, subtract, we would get 18 out of 36. All right. Let's move on. So determine the odds against having a sum. Ooh, odds. You're going to do that, eh? So we're going to determine the odds against a sum of 3 or 10. So the odds against, so what I'm going to do first is I'm going to calculate the probability of a sum of 3 or 10. So the probability of 3 or 10, these are mutually exclusive, so that's going to be the probability of 3 plus the probability of 10. And what we notice, the probability of 3, rolling a sum of 3, is 2 out of 36. The probability of rolling a 10 is 3 out of 36. Therefore, the probability of rolling a 3 or a 10 is 5 out of 36. So that's the probability. So the probability for 3 or 10 is going to be 5 over 36. So now there's 5 favorable outcomes, a total of 36. That implies that the total number of outcomes that are not favorable is 36 minus 5, which is 31. So the odds for are going to be 5 to 31. But the odds against, which the question is asking, is going to be 31 to 5. All right, determine the odds in favor of having both dice even numbers or a sum of 6. So you could figure this out using the previous methods, or you could use a little bit of logic. So determine the odds in favor of both dice being even. So I can go here and look where both dice are even. So that occurs, I'm going to just simply put a 1, 2, 3, no, 4, 5, 6, 7, 8, 9. So both dice are even. That occurs 9 times out of 36. Now, I'm having a hard time picking this apart. Both dice of even or a sum of 6. Okay, or a sum of 6. I don't know if they're mutually exclusive or not. And I actually do, but let's pretend I don't. I can still use the probability of A plus the probability of B minus the probability of A and B. Okay, and we're still going to use that because if they're mutually exclusive, this last part will just disappear. So this is the probability of both dice will be even. Now the sum of 6 occurs 5 times. So the probability of a sum of 6 is 5 out of 36. And now that helped me out because when are both dice even and a sum of 36, both dice are even and a sum of 36 happens when 4 and 2 or 2 and 4. So that happens 2 times out of 36. So really, if I add everything together, I get 12 out of 36, or the probability can be simplified to 1/3. Now notice I want the odds in favor of this happening. So remember that the top signifies, the probability for signifies the number of outcomes that are favorable. The bottom signifies in probability the total, but in odds, that implies then the number of unfavorable outcomes is 2. So the odds are 1 to 2.